Have you ever wondered if we could go live in space, where would we live? Some obvious answers are Mars or our beautiful moon, but perhaps the most livable of them all is one of Saturn's moons, Titan. It's way more like Earth than Mars is. In fact, it's the most Earth-like body in the solar system. So the question is, why haven't we gone there? This loaded question has a multitude of answers, but let's first explore why Titan has been considered for colonization. For starters, its atmosphere is actually a bit denser and has more surface pressure than Earth. Mars has only less than 1% of our surface pressure and is also constantly attacked by solar wind all the time, while Titan is protected by Saturn's magnetosphere. For the first time, NASA will fly a drone for science on another world. The Dragonfly mission will explore Saturn's icy moon while searching for the building blocks of life. It will launch in 2026 and arrive in 2034. Once there, the rotorcraft will fly to dozens of promising locations on the mysterious ocean world in search of prebiotic chemical processes common on both Titan and Earth. Titan is an analog to the very early Earth and can provide clues to how life may have arisen on our home planet. One of the most crucial questions is how will it handle communication being 1.4 billion kilometers away from Earth? Dragonfly uses direct-to-Earth or DTE communications, with transmissions from the lander beamed directly to NASA's Deep Space Network. Were there an orbital asset in place, then Dragonfly could communicate through it, but none are planned at this time, so DTE is used for all uplink and downlink communications. It is one of the most exciting missions in the history of spaceflight. It'll transition directly to powered flying from atmospheric entry. It has an incredible design to keep all of its parts warm with distributed heat without melting the ground it's resting on. And it'll operate by making hops of several kilometers roughly once every day on Titan, which is roughly 16 Earth days. That will not only enable it to move very far during its time on Titan and to study a wide variety of different areas, but while flying, it'll be gathering extremely high-definition imagery of the surface. Titan is shrouded by haze, so the data we have of the surface comes from infrared and radar measurements, mostly from Cassini. Being able to get ultra-high-resolution imagery of big chunks of the landscape several kilometers at a time is going to provide a wealth of data like nothing we've seen before. It should be able to last for years or even decades, though it's very dependent on its batteries as well, which might be the limiting factor in how long it can continue to fly. This mission promises to revolutionize our understanding of Titan's landscape and potentially unveil new insights about this fascinating moon. One of the older missions towards Saturn was NASA's Cassini, which orbited Saturn from 2004 to 2017, circling the planet 294 times and teaching us almost everything we know about our ringed neighbor. It measured the structure of its atmosphere and rings, as well as how they interact with the planet's moons. It also discovered 6 named moons, and revealed Enceladus and Titan as promising locations to search for extraterrestrial life. It provided a wealth of data on the planet, enough for researchers to analyze for decades to come. It measured the rotation rate, which proved to be more complicated than anyone had suspected, as well as the difference between the overall rotation and atmospheric motion. The probe's planned landing site looked a lot like a shoreline, so scientists were unsure whether it would touch down on solid ground or splash into a liquid sea. Rather than a splashdown or crash landing, it actually landed with more of a splat in Titan's mud, a sand-like material made up of grains of ice. The images sent back by Huygens also showed rounded cobbles of ice strewn across the area. These cobbles are likely made of hydrocarbon and water ice, and are thought to be smoothed by flowing liquids. Observations from the Cassini orbiter have identified several large seas and hundreds of liquid hydrocarbon lakes speckled across Titan's polar regions. Scientists believe that Titan experiences a seasonal ebbing and flowing of liquid on its surface with intense bursts of torrential rainfall and flash floods, composed of methane and organic compounds, cut by drier periods during which this liquid evaporates. The lakes around the moon's polar regions reflect this cycle, shrinking and growing depending on the season. Many of Cassini's most exciting findings were not about Saturn itself, but the rest of its system. Some of these regard its majestic rings. It found that they are made up of chunks of ice and rocks ranging in size from smaller than a grain of sand to to the propeller moonlets that cut gaps through the smaller particles. The spacecraft peered through the moon's dense, hazy atmosphere. The probe also took crucial atmospheric data as it fell through the haze and sent back pictures from Titan's surface once it landed. These measurements revealed an atmosphere full of complex molecules, clouds of liquid hydrocarbons, and seas of liquid methane and ethane, the only liquid seas we've found on the surface of any world beyond Earth. They also provided evidence for a liquid water ocean beneath the huge moon's surface. All of this together makes Titan a good place to search for alien life as well. What's more, the moon's got a water cycle going there, but perhaps here is where the similarities with our planet end. It isn't water that forms the Great Lakes, the clouds, and the rains of this moon. No, it's methane. Titan is probably the best name for this huge moon. It's the largest moon of Saturn, and the second largest in the entire solar system. The surface of Titan is one of the most Earth-like places in the solar system, at vastly colder temperatures and with different chemistry. Here it is so cold it's minus 179 degrees Celsius, or for the Americans, minus 290 degrees Fahrenheit. Titan may have volcanic activity as well, but with liquid water lava instead of molten rock. The moon's surface is sculpted by flowing methane and ethane, which carves river channels and fills Great Lakes with liquid natural gas. It only receives at most 1% of the sunlight we get on Earth, and even less on the surface because of the thick atmosphere. If you thought it's the perfect place to chill in space, well, think again. Humans would be miserable from the lack of sunlight. It is one of the 7 gravitationally rounded moons of Saturn, and the second most distant among them. It's very unlikely microorganisms are present because of the low availability of energy in that environment. Very cold surface temperature, like minus 180 degrees C cold, making chemical reactions for life slower, thick clouds masking out the sun preventing good photosynthesis, low gravity, and a less rich environment. Earth has a more dynamic and extreme geology, making many more elements, metals, and compounds available. Water is present but is solid as granite on the surface, rendering it mostly unavailable as a solvent, and the existing solvents and weather are hydrocarbon-based in the atmosphere and surface. Scientists are eager to learn more about Titan's potential for astrobiology, which is the study of the origins and evolution of life in the universe. Titan is an ocean world, with a sea of water and ammonia under its crust. And as scientists look for pathways for organic material to travel from the surface to the ocean underneath, impact craters offer a unique window into the subsurface. The new research also found that one impact site, called Selk Crater, is completely covered with organics and untouched by the rain process that cleans the surface of other craters. Selk is in fact a target of Dragonfly mission. NASA got its first close-up encounter with Titan some 40 years ago on November 12, 1980, when the agency's Voyager 1 spacecraft flew by at a range of just 2,500 miles. Images showed a thick, opaque atmosphere, and data revealed that liquid might be present on the surface. If there is life, and there very well could be, it's likely to be simple microorganisms, living in slow motion, and evolving and reproducing very slowly. Similar to life on Earth, which exists in the dark and cold bottom of the oceans, or surviving on slow chemical processes in pockets of water in rock and ice. Interesting to note from this, that in comparison we are wildly energetic luminous flesh giants, flying about crazily in our environment at high speed, thriving in the thermal and chemical energy available to us. So why exactly would it be preferable to colonize Titan instead of Mars? Well, for starters, Mars is a toxic radioactive wasteland with no magnetic field and electrically charged dust that destroys electronics and shreds your lungs, where solar panels are useless because of dust storms that can last for weeks at a time, and wind turbines barely function because the atmosphere is so thin. First you'll freeze, then suffocate, then get cancer. Want more? Okay, you asked for it. The worst part of Mars is its gravity, which is 0.38 that of Earth, which would cause slow deterioration of people who lived on it. But even worse, any children born on Mars would face even worse effects, since they can't exercise for 9 months in the womb or right after they're born, so they would have extremely weak muscles and brittle bones. Over probably 1 generation, you'd have people that wouldn't be able to go back to Earth and would quickly become a different species that would likely be incompatible with humans. Although this is debatable among scientists, but Titan is protected from stellar radiation by Saturn's electromagnetic field, has a dense atmosphere that can support wind power, and has widely available hydrocarbons to burn for energy and heat, and no fine radioactive dust that can destroy electronics and end up in your lungs. Titan's lower gravity and dense atmosphere also means it's significantly easier to land and take off from the planet. Parachutes can do all the work, whereas on Mars we literally drop rovers from orbit wrapped in inflatable cushions to break their fall because parachutes are so ineffective. And while Titan does have a thick atmosphere, its escape velocity is only a third of Earth's, and the Moon is smaller than Mercury, meaning takeoff would be significantly simpler. Short of the lower gravity being a significant health issue to overcome, the atmosphere being entirely nitrogen, and the long travel times, Titan sounds much more pleasant, to be honest. Comment your thoughts below. Don't forget to like, share, and subscribe to our channel.